All right, I'm going to assume that you've now had the opportunity to read that section on making polymers as well as isomers. If you look at it closely, I just kind of alluded to it because I kind of put the equation up and said that if you take two monomers and you add them together, dehydration synthesis, and you get that water. And that right there should be the same equation that you've been looking at. So when you look at this, there's the equation. It goes all the way through. And that's what we've been talking about. And so it's important to recognize that that happens in the human body all the time. So question is, what's an isomer? Okay. An isomer is this. If you look at glucose, glucose is C6H12O6, right? And if you look closely at the book, fructose was also C6H12O6. And the book doesn't mention it, but galactose is C6H12O6. So you ask yourself, well, how could all three of these be named differently, but all have the same chemical formula, correct? Well, basically what it comes down to is it comes down to how they're arranged. And if you look closely at the book, it's just the way in which the molecules are arranged in that atomic configuration. And so it's important to recognize that that's what makes an isomer. An isomer is something that is very similar chemically as far as the chemical components of it, but it's different in how it's arranged.